Hey, hello friends. Hope you are doing well. So today we are going to discuss the problem Leetcode 1368, which is kind of a minimum cost to make at least one valid path in the grid. Okay, let's look at the problem. So you are given a m cross n grid. Each cell of the grid has a sign pointing to the next cell. You should visit if you are currently in this cell. Okay, the sign of the grid ij can be 1, 2, 3, 4. So basically they have mapped kind of four directions. So you can go either up, down, right or left with the integers they have mapped. So 1, 2, 3, 4 denoting kind of these four directions. So 1 is for kind of a right, 2 is for left, 3 is for kind of lower cell that is down, 4 is for upper cell that is going up. Okay. So this 4 let's write it down. Okay. Somewhere here. Okay. Or maybe on the same we can utilize the so basically you have four directions, right, in which this can go from a cell. So either we can go right, left, up or down, right? And there are four symbols. For right the symbol is say 1, right? For left the symbol is 2. For up the symbol is 4. Down the symbol is 3, right? So 3 is for the lower cell. Okay, that's how they have denoted it. Now notice that there could be some signs on the cells of the grids that point outside of grid. Okay, so you'll initially start at the upper left cell, that is 0 0. A valid path in the grid is a path that starts from the left cell 0 0 and ends at the bottom cell. Okay, so this is 0 0. This is the kind of the initial starting point, or maybe m minus 1, n minus 1 is the this bottom right. Okay, so we can assume there are m rows and n columns. Okay, so yeah, you can modify the cell, you can modify the sign on a cell with cost equal to 1. You can modify the sign on a cell one time only, return the minimum cost to make the grid have at least one valid path. Okay, so basically if we start following these cells, okay, so for example here kind of we are going right, we are going right, we are going right, we are going right, we'll end up nowhere, right? This is kind of outside of my grid. Okay, then I might need to change this sign. Okay, for example, if I started changing this sign to, let me erase this sign and let me change it to down, right? Oh, okay, let's think. So rather than this red sign is I'm changing right here. So yeah, if I'm going down from here, okay, so I changed it, right? Now here also, if I go down from here, I changed it again. I go down from here. Now I reached here, right? That's how. So how many modification I need to do? 1, 2 and 3. So 3 modification I have to do if I want to reach from this node to this node, right? Otherwise I keep on following. So here I follow the same sign which is there earlier. I followed again the same sign which is there earlier. So I keep on going right, right, right. Here I can't go right, right. So I need to make a change to go down. Make a change again to go down. Make a change again to go down. Now I reached at my destination. So how many changes I need to do? 3. Similarly, we need to find any other like path from this node to this node which will give me kind of minimum modification I need to do. So could be like, for example, here if, let me give you another say example. For example, mm, Okay, if down would have been there in the starting, okay, and here again, let me erase it, just a minute. Yeah, here also, if I would have had down sign, okay, then here also, let me erase it. Here also, if I have kind of downside, so I could have followed kind of what here I can follow right, 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 then down, okay, then left, okay, then left, left, down, right, 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 down, okay. That's how I reached here. So I need not change any signs if that was the original array that was given to me. So if there are kind of right sign, right sign, right sign here, then down sign, then left, 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 down, right, 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 down, then I would have reached here without any modifications, right? So basically right now I'm telling you these signs as right, left, up and down. They are given as numbers, right? I mean, you can denote it with numbers as well. So for one, I mean, if you say one means right, you say four means up, you say three means down, you say two means left, right? So that's how they are denoting these numbers as um, the values in the matrix, okay? Now we need to find a path which has, I mean, I can reach from this to this with minimum modifications. So that minimum modifications I need to figure out. I mean, that could be 0 and that could be some number n, right? So yeah. Now let's think about, I mean, since I've already, I mean, seen this problem before, so I mean, let's see how best I can explain you the solution, but say very, I mean, this problem is really close to my heart. So basically, if you see, uh, if you start thinking from here, if there is a right sign in the starting, okay, then again there is right, and now there is a up sign, okay. Now again here it's a down sign, or maybe yeah, it's a down sign here, and it's down. Okay, let's see. Here is a C. For now, let's think there are no other signs, right? Or maybe we can say kind of, okay, these are the signs. Now let's see. If we are at this cell, we are standing at this 0, 0, right? We are standing at this cell. Now tell me, if I don't do any modification, how many cells I can touch? I mean, if I can from here, okay, if I just, okay, do it here. So I can from this cell, right? I can go here, correct? From this cell, I can go here. Here I can go, can't go up, right? From this cell, I can only go right, right. So only these three cells I can touch, right? I cannot touch more than that, right? Without any modification. So if my destination point was this, if my, let's see, think of, if my destination point is this, I can reach here without any modifications, right? Correct? Now, think, if we do one modification right now, okay? If we do one modification, so that one modification could be, so without any modification, I can reach here, right? Now with one modification, Let's see how many things I can touch upon. So let's see, if I do the modification here, instead of right, if I say I'll go, say, okay, let me choose another color, this one, maybe this one, yeah. So if I say I'll go down, okay, this is one modification that I have made. Now with this one modification, how many cells I can touch? I can go here, right? From here I can go here. From here I can go here. From here I can go here. Here. Any other cells I can touch? From here I can go, right? And yeah, here I can go down, correct? No. I mean, with this one modification, I can touch all these cells. Okay. So kind of without any modification, I can reach, uh, if I take another color, say, let me, so with without modification, I was able to reach here, here, and here. Okay. Now with one modification, I'll be able to reach, this is kind of a zero modifications, right? Now this is with one modification, correct? So with one modification, I should be able to reach, I mean, these many cells, correct? Now let's do another modification for now. Okay. If you now change this cell again to down, say, okay, will you be exploring more cells? See, if you, I mean, if you change it to down, you will come here, right? But this is already explored and this is going right. I mean, there's no point following that track because since this is an explode cell and it has not been changed, so everything else will be already added, right? You have already explored this path, kind of. Okay. So there is no point. Even if you now go up here, for example, you chose to go up, then also there is no path. If you chose to go left, then there is no path that is being explored as an addition, right? I mean, you are not able to explore any new nodes if you try changing all those four directions, right? Now, if you also try with this one, earlier it was right, you explored the down direction. Now, if you start exploring up and left, then also you will no more be adding any new nodes, correct? Let's try for this one. If you change the direction from up to right, I mean, then you might be exploring this again, then you reach here again. I mean, you'll stop exploring now because you reached kind of a dead end now. Okay, so that's how. I mean, what is now? This is one change. After one change, right? You kind of start exploring. This is after one change, one change, one change, right? So with one change, you are able to explore these many nodes, correct? Now let's see, if you do, this is the one change you have already done, right? Now if you start exploring this, if you change this to down, correct? Now how many you can explore? So this is your second change you are doing, correct? With zero changes you can reach this much. With one change you can reach this much, kind of. With second change now you will reach, kind of. I mean, now you are expanding your kind of exploration of nodes, right? You will be adding or exploring more nodes as soon as you are modifying these signs, correct? If you are earlier you are going right, you explored, I mean, all those. Now you start going down. Now you start exploring these as well, right? You explore this. Now, I mean, you will see now, maybe, I mean, you can explore this path. I haven't have the signs here, but you, I mean, maybe you are getting where I am going into, right? So basically, first of all, we need to see that without changing any signs, how many nodes we can explore. Now, change. the sign one by one. For take one node, make earlier it was pointing, for example, right. Now earlier it was pointing right, maybe let it point to left, then up, then down. So try all four directions. For each node, try all four directions. Okay. One direction was already, there, correct? I mean, there is either one, two, three, or four written on the cell. So one direction it is already pointing to. Now try all other three directions and see how many more nodes you can explore. Nodes, I mean to say, these are nodes to me. It looks like a graph, right? These are nodes to me, and they are connected kind of. This node, this is kind of 0 0, correct? This is 0 1. So these are kind of nodes. This is 0 2. They are connected, right? Either they are connected. For they are connected means, there is a right sign, so they are connected kind of. If you change it to left, then you are exploring these directions. So that's how, you are going, right? So I hope you are. So here, if you talk about the implementation, right? So I'm talking the mixture of BFS and DFS basically. So BFS I am using when I am adding all the nodes into queue which are being explored through DFS. Okay. So first of all, I am at 0 0, right? That's the node I am onto. Now I'll try exploring all the nodes without changing this sign. Okay. I'll add this to queue. I'll take it out and I'll see how many I can explore. So, all those nodes will have kind of cost zero associated because I need not change any signs. I need not change any direction or any signs on the cells. Uh, before reaching to those nodes, right? I can reach them directly. Now I'll change the sign one by one. I'll change it to, say, earlier it was pointing to left, right. Now I'll change it to left, kind of, and I keep on exploring. Okay. Let's think through. How we can write the code, and maybe that will be clear to you if I start writing the code. Okay. So let's see. First of all, okay, since we need to explore these four directions, right? So I should have kind of direction X array and direction Y array. Okay. So direction X array would be, since you, okay, since one is for right? So one is for right. Right means we are incrementing the Y, X remain constant. So X remain constant, incrementing the Y. Okay, so it will be +1 for this is incrementing the Y. Now then 2 means left. That means decrementing the Y, X remains same. Correct? You understood, right? Right, left. Now down is 3. 3 down means you are kind of decrementing, or maybe, yeah, down means you are decrementing your, you're incrementing your X, right? So so you are kind of going down. So sorry, let me check in the problem just. So when you are going down, yeah, so you are incrementing your X, right? Yeah, here it is also given. So you're incrementing the X and your Y remains, sorry, now you're decrementing the X, right? So these are the two directions array that we need to take. So let's see, let's return 0 just to resolve the compilation error. dir x we'll take dir y. Okay, now let's see zeros, as I explained here, 0 0 1 1 1 minus 1, right? So 0 0 1 minus 1. Okay, now y will be 1 minus 1 0 0 1 minus 1 0 0, right? Okay, now what we need to do, we are given a grid, right? Now it has some number of rows, right? Grid dot length, it has some number of columns. Okay, okay, now uh, I need to mhm. First of all, I'm doing two things, right? BFS to add nodes, explode via DFS, right? So I'll have a queue. Okay, and queue of say int array, I'll have a queue, so linked list. Yeah, now what I'll do is mhm, now I'll say okay, DFS, right? Basically it will take kind of a node which is x comma y, and it will determine how many nodes it can add. Mhm. How many nodes it can add to my list. Okay, we'll take x comma y, maybe we'll sing void for example, and it is also taking this queue, it is adding the nodes to this queue, right? Whichever nodes are being explored, it is adding nodes to this queue. Also I need something to check whether I have explored that earlier or not. Mhm. Maybe I'll take a cost array of the same size, that will be of size m cross n, and maybe if I say for cost array, if I say cost colon costs arrays dot fill cost with integer dot max value. Okay, I'm filling this array with say dot max value. Okay, now I call say DFS. In the starting I'll pass in 0 0, since we are at 0 0. I'll pass this queue, I'll pass this costs. Okay, now this costs array, let me okay, now so basically let me okay think. Hmm. So we are at 0 0, we are calling now DFS. Let's see how many we can explore from here, right? So like we have explored kind of till, so this node we have explored, then this, then this, then this. So we keep on iterating or following the direction basically. from here, right? So direction could be 1, 2, 3, 4. Okay. hmm Let me think just once again. So we need to explore 4 directions, correct? Okay. For example, I'll do this. I'll add into this queue. I'll add this 0, comma 0 first. Okay. Maybe new int 0, comma 0 first. Okay. Now I'll say while queue dot is empty. I'll pull from this queue. hmm I'll say node. Okay. I'll pull from this queue. I'll call DFS. Okay. Yeah. So let's look at it once again in the. So basically we are at 0, 0, right? So we need to explore all the nodes from 0, 0, add them into queue. Okay. That's how that DFS thing works. Okay. And when we start from here, we'll say cost of this is 0. Figure it. This is 0. This is 0. And this will be incremented once the node added in the queue got like pulled up, and then it will be added in the next iteration. So we also need to keep the size of the queue. Yeah. So think here. So okay, let's do it one by one. First take a cost thing. Okay. Let's kind of make this as say min costs. Okay. Maybe rename it to min cost. Okay. Now kind of check the size of the queue first. Okay. Now kind of iterate on that size. Yeah. Let's say node. It'll be a node. Add some. Now we run kind of DFS from this node. Okay. It will be node 0. node. So this x, y, and the q, okay, and maybe min costs, right? So this is what will be passed. Okay, now let's finish up first of all, I mean, this DFS. Okay, now first of all we'll check the, I mean, whatever coordinate for which this DFS is being called, that is not out of bound kind of. Okay, then we'll say we'll also take m and n. Let's pass in m and n here. Okay, for now let's remove this. Now x should not, if x is less than 0 or y is less than 0 or x is my greater than equal to m or y is greater than equal to n, then or I mean this minimum cost, min cost xy coordinate, I mean that is already visited, right? I mean if this is not equal to integer dot max value, okay, in that case we need to return. Okay, that's it. Now if like we explode a new node, what we need to do is first of all we need to set the minimum costs of that particular element, newly explored node. Okay, so what will be that cost? So let's take a cost variable here, and after every like iteration I'll increment this. And this will also be passed along this DFS function, and this will be the int cost. So for one iteration, how many nodes I am exploring, whatever nodes I am exploring in this DFS will have the same cost. Okay, now since this is a newly explored node, I'll add this to the integer array. Okay, I'll call DFS again. So I'll pick what is the value here. So for example, the value in the grid basically. So let me pass the grid as well, the original grid basically. Okay, let's check what's the value in the grid of x, y. Okay, we'll check the value in this grid, and now we need next x and next y, right? So we'll, since the values in this grid are 1 2 3 4, but we need to map it to 0 1 2 3, right? Since our directions support this, so we'll say value -1, so x plus direction. Okay, these will not be visible, let's make them global kind of. Okay, x plus direction, this, comma, y plus direction y of well -1, comma, q min costs m n cost and grid, right? That's what I'm doing, correct? Now, okay, I'm setting the costs, I'm adding it in the queue. So for the first node, it is already done, right? So, I mean, since for the first node, it is already done, I need not add it here. Maybe I can call DFS maybe from here for the first node. That will automatically add it for me, right? So kind of this is this 00 node I'm calling DFS. Okay, this is the queue min cost. Okay, let me shift it bit up. Okay, now this cost will be 0 in the starting, right? And the grid. So this will add up all my kind of 00 into this since 00 is a newly explored node kind of, so this will be added into the queue. So now I need to try for all four directions, right? I'll pull it. I'll say int k is equal to 0, k is less than dir x dot length k plus plus. Okay, now I'll run this DFS for all the directions, right? So I'll say grrx of k dry of k. This is a new x new y in the queue. Yeah, we are already incremented kind of. So yeah, it is happening inside this, and what will be returning is the value at min costs array, right? So it will have kind of m minus n minus have n value will have the minimum cost. So incrementing the cost for the next iteration, pulling the value out, explore all the edges, okay, and make sure visited is being marked. So this min cost is acting for both. I'm kind of, it is acting as a visited array as well. So I should not visit if I've already visited that particular node, and it is also acting as kind of cost calculator for me. So every time I'm visiting a node, I'm setting the cost as well. Okay. Mm. Let's revisit it again. So cost is 0, length I've calculated, then I've formed kind of a min costs array, set all the cells as max value. Okay, then I've created a queue. I did DFS from my first node. Okay, the cost is 0, grid I passed. Now I'll check if the queue is not empty. Queue is not empty since 00 is added and all the others will be added here. So I'll say cost is now 1. Say put the take the size. Now run this loop as per the size. Now pulling out the first node. Now going like exploring all the four directions from here. Say node 0, node 1. This is x plus dirx. Yeah, I think this should work. Let's try it out. Yeah. So thank you so much, guys. It's a long video. Um, Please, I mean, give your comments like how we can improve this channel. So yeah, that's all. Thank you so much.